Hi guys, this is Mark. In this video, we'll talk about transaction isolation. It is a very important subject to understand. It comes into play whenever you start building logic or writing code that uses transactions. It is applicable not only to Backendless, but with a lot of databases that support transactions. Let's talk about isolation. What is it? So transactions, they become quite useful in order to provide consistency and integrity of your data. If you consider an application that has a lot of concurrency, where there are a lot of users hitting the database at the same time, and quite often multiple users would be modifying the same database record, the same object that is stored in the database. So the isolation will, or the policy of isolation that you pick, will give you some form of isolation of that object, just so multiple users are not stepping on each other's toes. So we will review all models of isolation, of transaction isolation that are present in Backendless. To start, let's take a look at what the isolation models are. In Codeless, whenever you create transaction and there is a block that creates a transaction, you can actually pick an isolation. The one that is selected by default, it is repeatable, read, and I know that may not make a lot of sense since we're just getting started, but I'm just going to say that repeatable, read is the default one, and it works for the majority of the cases. However, it is going to be important to actually understand what other isolation modes are, because you may need to pick one over another. They have their own pros and cons. They may have some consequences in terms of performance, and but let's just dig into it and see what these isolation modes are. First one is going to be read uncommitted. And for this, we will consider a very primitive data table that has a column name and age, and there is one record for this table. So let's just consider that transaction 1 starts, and in all of these diagrams that I created, this green line will represent time, and then just consider that time goes on and there will be various events occurring on the timeline. So let's say this transaction 1 starts, and that transaction performs an update of that record. So the age changes from 23 to 24. Keep in mind that when transaction is executed, whatever changes that I'm making, the final version of it does not really end up in the database fully until you commit that transaction. So in Backendless, whether if you use Codeless, you would basically say run transaction, and when it starts executing everything, once it is done, everything is committed. If something fails, it will roll everything back. So this is sort of a pending change where we did this update. And then let's say that at the same time or slightly later, transaction 2 starts, meaning some other user starts executing some kind of operation. So this transaction 2 starts, and then transaction 2 needs to retrieve data. And then we're talking about retrieving exactly the same object. So with read uncommitted, whenever we do read data of that very modified object, you will actually get the modified version of it, even though these changes are not committed. Okay, so then transaction 1 commits, and then transaction 2 commits, and then if everything goes well, okay, then transaction 2 got the modified version while that object was not committed yet. And that's read uncommitted. So now the read uncommitted term actually makes sense, because you will be getting that data back that is not committed, that is modified by a pending transaction. So that's read uncommitted. Now, what this also may be referred to as dirty read, because that read is not final, that object version of it is not final because it is not committed, but you still get to access it in the form that was present as a result of some other uncommitted transaction at that time modifying that object. So that's read uncommitted. The next isolation mode is read committed. Again, same data table, same data. So let's say the transaction 1 starts and performs an update. And then second transaction also starts and retrieves data. So as you can see that the data that it gets is the actual last known good data, the one that hasn't been modified by any uncommitted transaction. So far so good, because both transactions actually see data as it was before any other transaction started, or even though while some other transactions are running, you still get last known good data. Then transaction 1 commits, and then let's say transaction 2 does retrieve data again. So at this point, the latest and greatest version of this object is Joe24. So if you do retrieve data after the first transaction is finished, then you get, again, the latest and greatest good data that is in the database that is committed. And as a result, we get this phenomena where we did retrieve data in the second transaction twice. Timing is important. This one was before the first transaction committed, and this one is after. And as a result of this read committed, you got two different versions of that object. So then the second transaction commits, and then what we get is a phenomena that in the database lingo is called non-repeatable read, which is sort of a side effect of the read committed isolation. And then this is not to say whether it's good or bad. I'm just laying out the options and describing how transaction isolation works. So with read uncommitted, there is a phenomena of non-repeatable read that could be happening whenever you have multiple transactions running. So the next one is repeatable read isolation. And let's take a look at how this works. So transaction 1 starts, and then it retrieves a data set. Okay, so let's say that this is the data set that it got. And we have slightly different table here. We have name and status. Actually, status is misspelled, it's missing T, but let's just say it is status. So we have Anna, which is an employee, and Joe is a contractor. Then we have transaction 2 that starts, and then it does an insert. So it inserts a record into that table. Okay, and then transaction 2 is done. So all it did is basically just inserted data. Then the transaction 1 does an update of that data table and just modifies all values in the status column to be employee. And then it retrieves it again. All right, so it retrieved, and notice that the first time we retrieved, we got 2 records, and the second time we retrieved, we got 3 records. Okay, so this inconsistency is just a side effect of the repeatable read, simply because while transaction 1 is running, some other transaction modified our data set. Okay, and because it modified the data set and committed that transaction, these 2 retrieval operations, they return different set of data. And then transaction 1 commits. So this is basically repeatable read, and the phenomena that again, every single isolation has its own phenomena. And then the phenomena in the database lingo that we are observing is going to be called phantom reads, because the first retrieval gave you one data set, and the second one gave you a different data set. So that's the repeatable read. The fourth isolation mode that I don't have a slide for, because you will find out why, it is called serializable. And then serializable gives you the highest level of isolation. And what that is that every single transaction, whenever it starts, whatever the data set that it gets, the data set is sort of is so isolated where whatever you're doing with it, that transaction has that data locked to that transaction. Okay, so if you have 2 different transactions running in parallel and they are retrieving data and they got that data, whatever they're doing, it just stays with that data. And the first one commits data and it goes into the database, and the second one commits data and it goes to the database. And if there are some conflicts with data integrity, just because you may be referencing an object that was removed by the first transaction, then you're going to get an error, and then the whole thing will be rolled back. So serializable, while it sounds good because great, you get complete isolation of everything, it will not be as performing, just because database has to maintain so many different copies of all your data that it will just start impacting the performance. And you will be running into a situation where while everything is isolated, as transactions commit their data, you will be running into situations that data becomes no longer valid, and some transactions will be rolling back. So, but still, that's the serializable isolation. Let's go back to the very first slide where we have a list of those isolation modes right here. So as you can see, serializable is there, and repeatable read is the default one. There you have it. That's the kind of a quick rundown on the transaction isolation. Repeatable read works for the most cases, and for this reason, it is the default one. So whenever you're designing your transactions, I would say go with repeatable read, unless your application really has some very special requirements for how data needs to be handled. But understanding these isolation modes, as I just described them, is definitely going to be very useful when you start building your applications. Thank you for watching this video. I hope you found this useful. And as always, happy coding.